Okay. Hello, everybody. Thank you for being here. Today I arrived from Moscow, as you know, and I'm really excited to be here. And before I will start, please take a minute to introduce myself. Okay. Thanks. Okay. Last 16 years, I've been involved in software and web development, as you see, and last 6 years, I'm being full focused on front-end development. I made 15 projects, including single-page applications, high-load React during these 6 years. I like open source, and I made some comments in Webpack, in Redux, and Core. Maybe you something heard about these projects. I've been able to speak at biggest Russian conference, such as High-Load, Agile Days, you can see, and other things. So 2 years ago, I founded a company, Startup Makers, where we made web and mobile applications for our customers. We also do DevOps things for this. Thank you. And we use latest and right things for this, such as React Native, React, Redux Relay, Kubernetes, CoreOS. We have 20 members, 21, and we are striving to be the best in our sphere. So, why should we stop to develop classic single-page applications? How does isomorphic applications affect your income? What will you be doing at this weekend? Okay, go ahead. Part 1, architecture. Today, web became a serious environment. Web development became something middle between art and science, yeah? Especially front-end development. How easy it was. Maybe somebody remember, yeah? Just create a HTML file, add some scripts, maybe by usually Node, and submit to production via FTP. Then browser submits request to server, and the server does everything, and the response with HTML, maybe sometimes CSS and JavaScript. And it worked, yeah? It really worked. But later we got segmentation in web development. Some developers was focused to browser things, yes, and some developers was focused on server things. And we call this front-end a back-end. Like, for example, front office and back office in business, yeah? So it was good, but during time we found that changes are delivered with a delay because, for example, you can make some things in front end, but backend API is not ready for your changes. Maybe somebody got these things. And later we get single-page applications. Single-page applications changes our architecture. And browser submits request, and in server just check, does the page exist? Do we need auth for this page? Do we have access to this page? That's all. And then server responds with teeny HTML, CSS, and big JavaScript bundle. Then your front-end application JavaScript bundle is communicating with server via Ajax and iframes. Does anybody communicate with server from iframes? Yeah, yeah, very old guy like me. Okay, we got a lot of benefits with this approach. it was easy to start, yes, because we can just create a simple HTML with one div. We can just add React, Redux to JavaScript bundle and compile it via browserify, Webpack, or something else, yes. Rich features, it means we can use everything which browser provides us. We can use everything, HTML5 and other things. Fast enhancement, it means you can just connect new components, new plugins, jQuery plugins, Angular plugins, React plugins, and it just works, yes. And responsive UI. Responsive UI doesn't mean about mobile. Responsive UI, it means when you click on button, you will get reaction immediately. You have not to write server for response, yes? You can just show spinner, for example, but any reaction you can show immediately. And defaultless caching, of course, because JavaScript bundle is easy to cache by your browser. So you can ask me, wow, is it so ideal? What's the problems? So, okay, about problems. A long time to start. Usually, a JavaScript bundle in single-page application has size up to 3-5 megabytes. Somebody can optimize that, but usually it's about 3-5 megabytes. It's real. Browser first request to these applications cost a lot of time because we have download big data, big file. And browser need a lot of resources to execute and to run this file, yeah? JavaScript. Expensive maintenance, it means when you mix all components, all extensions, all parts of your application in one JavaScript bundle and a lot of pages implemented in one JavaScript, you easily can get side effects. When, for example, somebody in your team add new component and it affects on other pages in applications. Maybe you will get this. Maybe you got this. And memory leaks, of course, because when you mix all components in one JavaScript bundle, it's very complex, and some components provides memory leaks. Empty page, it's usually how build single-page application. One URL and empty page with JavaScript bundle. And in this way, it's hard to support legacy browsers. Really hard, because we have to avoid to decline support old browsers because otherwise our JavaScript bundle is very big. Became JavaScript or jQuery avoided to support all browsers. So are they really costs? Let's have a look at single-page application from business side. Long time to start means you will reduce UX for your application. 2 years ago, Kissmetrics made analytics, and where they show page load delay for 3-4 seconds, reduce reduce page load time for 4 seconds, for example, provide you page abandonment 25% and more. For example, if e-commerce site is making $100,000 per day, a 1 second page delay could potentially cost you $2.5 million every year. It's not so cheap, yeah? For 4 seconds, yeah? So expensive maintenance. Expensive maintenance, when you have a lot of side effects, it means also, for example, risk to out from budget and out from dates, yeah? When you try to keep deadlines. And empty page, it provides you zero problems. Of course, Google can execute your JavaScript applications, but Google does not do it very well. And for example, other search engines like DuckDuckGo, Yandex, Bing.com, they can't execute your JavaScript. And index, for example. One rule also means you will get social sharing problems. Yes, when somebody try to share a page, for example, like Medium article, yeah, it will produce problems because you use one rule. Legacy browsers also provide you lost audience. Does anybody know how much users right now in global market share of year 8? Does anybody know year 8 in global market? How?
Only 9.
8%, yes. 8%, yes. And with year 9 included, it's around 10%. It's very much. So that's all means for business losses. So what should we do How do we solve this problem? Take the best from both worlds. I mean isomorphic application. By isomorphic applications, we generally mean that even given line of your JavaScript code, generally, can be executed on with notable expectations, yeah, exceptions on client side and on server, and now it's also and React Native in mobile. So generally, isomorphic applications looks like this. You have some files like start points, server, worker, for example, server is web server, workers, somebody background work, and front office, for example, client is public, and admin is some back office, for example, admin tool, yeah? And now we have also React Native applications. Somebody heard something about React Native? Oh, wow, very good, great. So React Native is two. Can be isomorphic. So generally, isomorphic applications looks like your browser submit request to front-end server, which is written on Node.js, and this server, Node.js server, is handles this request and get data from external API, from database, from Java, PHP, any else your backend previously, and then compile HTML with this data and provide with critical CSS to browser, like in 2000 era, for example, when we don't have client JavaScript. And after that, we respond with JavaScript bundle, which is a single-page application, and we have full JavaScript application in browser. And this JavaScript application can communicate with backend from your previous backend. Also, you can do it with front-end servers, but generally you can just do it with directly API. So, in this way, we can get a lot of benefits. The main is one execution environment where you can execute your code in one environment, and you can scale your team for a lot of projects. Shared codebase. When you develop once some components from some screens, you can share it, for example, on mobile application. You can build, for example, from your web application, from your React application, you can build a few days mobile application, which is really works like native, and full control, because you can control backend and front end, and one ecosystem. Of course, it's NPM modules, components, microservices architecture. I will describe right now about this, but Microsoft microservices architecture is very powerful way to scale your application with growing. So yesterday frontend was only a browser, yeah, backend, but today frontend is browser and the server. So we have one more chain. So how can we do it? How we can generally about behind isomorphic applications, we understand server-side rendering. Server-side rendering, it means we build our HTML on front-end servers, and we render page in your browser immediately before it loads any JavaScript code on browser. And when your JavaScript code will be loaded, React just add event handlers, and your HTML became live. So in this way, client and server use a shared codebase. You just write it once and it works everywhere. And it works really very well and very fast. So this short example how to do server-side rendering with React. You can download this slide with following examples. There is a render to string function which render your React components just to plain strings, and you can respond it to your browser in Express, for example. So visitors see a page immediately, no additional request to load data. Page could work even without JavaScript. It's really full URL navigation. You can have you can have a lot of URLs for every page of your application, and you can build very complex navigation, like Medium, for example. You have meta tags for SEO and social media marketing. Again, media, you can share any page of your media article, and you will see for every page when you share it in Twitter and Facebook, you can see description, photos, and such other things, and better security. So part 2, performance and scalability. I mean functional scalability, not performance scalability in first. Server-side rendering is very easy when we have data before we build a component, before we push component with state. Yeah? But what if we have to load data before in async mode? For example, from database, from any other third-party resources. To get this, we can get async state. To get this, we can use one of this way. For example, we can load this data in manual mode before for each page. We can use declarative data fetching, such as Facebook relay, and we can organize request promises. I will describe about that later. So manual data fetching for each page, it means we just define that data which you have to load for each page. You then load it and render your components with this data. It's easy. So Facebook relay. Does anybody know Facebook relay? Well, almost all, half. Okay, good. So you know, yeah, Facebook is a framework for building data-driven React application, and also it provides declarative data fetching. And in this year, relay also can work in isomorphic on server side. In this repo, you can download sources which can provide execution of your relay components, relay containers on server side. So the next thing is request promises. We will use Redux for follow examples. Redux is state containers, you know, is close to be a standard for React applications here. And I talked about Redux at previous year. So let's go. Generally, we have two ways to do it, to request promises, to provide request promises approach. We can call static methods for components for specific route, and we can just render elements tree without data. Then we collect all promises that allowed promises from each component which submit promises, and we render all elements tree with data, with fetch data. The first one is we just create Redux store, link Redux store with route middleware, and then we dispatch match action for requested location. Then we just add response handler for one property in store, which is promise, and when this promise will be resolved, we just respond it with data. So in schema, it looks like we have our express route handler get request from user. Then we create a store, find component for route, for requested route. Then we wait for resolving fetch data, which is assigned for this route, and we render components with data. So next you can see a short example. It's for component, it's for route, it's for how to do it on Express callback. You can see it in details when you can download these slides. I just provided for your future. This way implemented by React router Redux, this latest router. And Redux router is router made by Andrew Clark, maybe no. So, but what if you need to computing some data to fetch before dynamically? What if you have to delegate decisions about requests down to the tree, like with relay? For this way, we can implement, for example, we render our components tree without any data. In constructors of our React combinations, we call callback with promises to fetch data, and we later wait until these promises will be resolved, and we re-render all elements tree with fetched data, and it will works very well. For example, you can load from any level of components. I will provide sources and example here. We implemented some projects with these solutions, and it was really useful. Really usable. Okay. So performance. As test end, we have used this MacBook, and it was a middle page, without graphics, just HTML, 56 kilobytes. It looks like one screen, two screen, four, and other. Yeah. So we will test it with AB. AB is Apache utility for testing benchmark. With this command, we send 100 requests to this URL. And when we execute it, we got time for request 62 milliseconds. So 62 milliseconds for this MacBook. Is it slow or is it not? How do you say it? Just take a pause. How do you think? Slow. For this, it's good. Slow, yeah? Or fast? 62 is good enough. Okay. So let's try to do it with handlebars. With handlebars, we will get 8 milliseconds. So I think that it's slower. How to make it faster? Okay, try to search in Google, nothing. Try to ask on Twitter, nothing to silence, absolutely. Okay, what if we do that? What if we just not have production? Ta-da-da-da! Good. Wow! So simple, yeah? But nobody told us about this. It works, good. So looks better, really, but still not so funny, yeah? Go ahead. We can search in GitHub issues, and we can find these issues about server-side rendering slower, yeah? And a lot of discuss about authors of React, a lot of fight. So, and solution, use directly this file, this model in your React package. Okay, let's try to add this file, and to use in production, just minimize it, React. Okay, how does it influence results? Let's try again. Oops, something was wrong. Really, it was slower. So test file it, and we can see this benchmarks. Whereas Node-env production is most performant. So conclusion, for example, in this issue, always use Node-env production when you start your application, yeah? Build. So really, we can optimize React server-side rendering seriously. In this way, we have to have a look at advanced solutions. Let's have a look for these solutions. For example, pre-compilation and cache, rendering separation, HTML streaming, Facebook BigPipe, and hub proxy. Pre-compilation and cache, that means generally UI is f from state, whereas f is your React component, state is path and combination of actions. Yeah? The simple solution in this way will be a cache output of your rendering for each path and actions in Redis, just plain HTML. But the most advanced solution will be use Redis and workers, background workers. For example, when you have really high load application, you have to respond immediately in hot house, and you can just in these moments you can just respond with spinner, and your workers can render it in background. In the next request, you can just download its cached HTML. The next approach is rendering separation. It's, for example, Netflix provide analytics about user behaviors, and they found that a lot of users on each request, do not scroll page down. And why we have to render all page? Why we have to render all page for each request? We can just render visible page, visible part of page, and other part we can just download by JavaScript dynamically when we show the first page, the first part, visible part. It's a very good solution too. Yeah.
It kind of breaks the idea of optimizing for a search engine, right?
What?
That kind of defeats the purpose of this being a available.
Yeah, but you can use user agent and to solve this. Good moment. So the next point is HTML streaming. It means usually we use the second one on optimized rendering. For example, we build all HTML on the server, and when all till the last byte is ready, then we just respond with all HTML. But we can use early flash. So, for example, when we compile, when we ready to respond with header, we can respond with that. When we can respond with the next part, we respond with this, and till the end of page. It works very well. At the previous React Group conference, Sasha talk about this. He made this solution, React DOM Stream, which can provide streaming, and it will improve in half your response time. React DOM Stream, React DOM Stream is something like a fork of React with a hack to stream server-side rendering. It's what?
What's the price you pay? I mean, for free, then they would include it in the actual official React.
Yeah. Yeah, this solution is only provide streaming, and he always updated to latest React version. It's just provide this like page, monkey patching, something like that.
Do you know the reason why it isn't implemented in the React, like from the very beginning, like in the Facebook React? Why
Facebook React.
They didn't do that.
What?
Why they didn't do that?
Because it's, there is why they did not implement in core React. A lot of discourse about that. It's maybe you know, yeah, because Facebook prefer such things which is actually for useful for them personal. They don't use this way because and a lot of discourse in Facebook you can find with this issue, and right now I can't ready to explain details because generally we don't use these solutions, but somebody can use according to your tasks. So Facebook BigPipe solution is very good too because, for example, it's something like rendering separation. There is typically a Facebook page, yes? We can extract some widgets here and just on first request, response with half-ready page. And user will feel that page is starting, something is starting. And it's okay, it's work like immediately. And then we just load remaining paths by JavaScript. 1, 2, 3 in parallel. And it works very, very well. There is Facebook post about this technology, it's working right now in Facebook. and hub proxy. It means you don't use to only one instance of your Node.js application. Yeah, you can just ask your DevOps department or DevOps engineer to configure multiple Node.js instances. Or you can just use CoreOS, Kubernetes, or Mesospheres solutions. Does anybody know Scale Cup? No? Okay, I will explain. It's about Art of Scale. It's from book Art of Scale about microservices architecture. It's how we can scale our microservices architecture. 3 dimensions. Y dimensions, Y dimensions is functional decomposition. X dimensions is horizontal duplication. And Z dimensions is resource partitioning. It means X dimension, when we scaling our application by replication components. For example, we have one instance, we can do it, we can make run some copies, yes, for example 3 or more, yes. It will be a horizontal X scaling. Also we can do Y scaling. It means by splitting our application by functional. For example, we can extract some things like catalog, like orders, like chats in separate servers or separate services, and we can balancing load traffics between these parts. Z scaling means we can do scaling by data splitting. For example, when we can split our content of our catalogs by letters, for example, range of letters, or by numbers. For example, if we will mean user IDs, yes, we can from 1 to million, from million to 2 millions, and other. And alternative could be splitting by resource class. For example, we can use one server, a middle server for regular users, and 2 dedicated servers for premium users. It's very good for products solutions. So let's begin and finish, okay? Jake sometimes once time ago said that changes is our work. Almost all algorithm problems could be solved by changing a data structure. So I asked you, why should we stop developing classic single applications? Let's take away and finish this. Classic single page application is very expensive for business. Yeah? Isomorphic applications provides better UX, SEO, social media marketing, and reduce risk and costs. Shared codebase and one ecosystem are good investments for high efficiency development. Server-side rendering performance is not good. It's real fact. But we know a lot of, right now, we know a lot of advanced solutions to improve it very well. And the microservices architecture is the best solution, where we will have the front-end server just a render service, and we can scale and play with this in scale cube model. So you can send me an email with your all questions anytime. You can write me something in Skype, on Twitter anytime. Feel free, and thank you very much for questions.